Hi, welcome to the subject Microcontrollers and IoT. In this first unit is introduction. In this class, we are going to discuss about the introduction to microprocessors and microcontrollers. In this class, we are going to differentiate the microprocessor and microcontroller based on their uses and applications. And first we see about the definition of microprocessor. It is a programmable device and it takes input from the registers from the outside and it performs some arithmetic operations like addition, subtraction, multiplication and the logical operations also, and then it will produce us the desired output. In simple words, we can say that the microprocessor is a digital device on a chip that can fetch instructions from memory and decode the instruction, and based on the instruction it will perform the operations and it will give the results as output. And we know that the microprocessor performs the three basic operations while executing the instruction. The first one is some basic operations like addition, subtraction, multiplication and division. Including this, the logical operations also performed using arithmetic and logical unit. Normally we called this is an ALU unit in the microprocessor. In addition to that, now the new microprocessors also perform operations on floating point numbers. In previous, it performs the decimal and hexadecimal numbers. Nowadays, it performs in the floating point numbers also. And the data in microprocessor can move from one location to another location using the register movement. And the microprocessor also having the register called program counter. The special application is it stores the address of the next instruction based on the value of the program counter, and also the microprocessor jumps from one location to another location for making decisions using the jump loop operations. Now let us see about the basic building blocks available in the microprocessor. The basic most unit is ALU. Now it is called as a arithmetic and logical unit, and another one is a flag. It is a register unit, and CU is the control unit, and the register array, it is used for getting the input and output, and instruction decoding unit and the PC address bus. Microcontroller. Now see about the microcontrollers. The microcontroller we called it as a small computer because yes, all the some performing devices are connected in a single integrated circuit that is designed to control specific tasks within electronic systems. So it combines the functions of a central processing unit, memory and input-output interfaces all on a single chip. In this diagram, we see that this is a single chip because microcontroller, it having the ADC, that is and clock, RAM memory unit, CPU unit, ROM, input-output phases and DAC, digital to analog converters and analog to digital converters. And now we are going to brainstorming the devices in day-to-day life. We know that laptops, smartwatches, washing machines and robotics. We know that the laptops will perform here common general operations, which is a high performance computing device, and it is a smartwatches means it is a wearable one and it performs the compact operations. And washing machines, we know that it is a automated household appliances. It performs the specific task based on the input which was given by us. And the robotics is used to precise the motion control, and it uses the specific application for the movement of a particular robot. So from these four devices, we are going to analyze which one is a microprocessor based and which one is a microcontroller based devices. Okay, so in this we are going to spend some 5 more minutes for analyzing this laptop, smartwatches, washing machines and robotics. And we know that the key differences between the desktop PC and washing machine. If we come to the desktop PC, means it uses a powerful microprocessor. Okay, it has external memory and no built-in peripherals, and it gives a high processing speed. And washing machine, it relies on a microcontroller because it performs the specific task focused one, and it has integrated memory, built-in input-output ports, and processor selection for applications based on our specific application or general applications. We can select the particular device. For industrial robot, it gives the precision control and real-time application, and automotive executive unit embedded safety features, data center server and drone control for flight stability and navigation. And we have to sketch the architecture based on your understanding in the previous slides, because it is the Intel microprocessor and it has the complex external bus structure, because it is not a built-in memory and input output unit, because we have to connect all the input output unit and memory unit in external only, the ALU and everything. But in the 8051 microcontroller, all the system units are in one chip only, all in one chip design. Okay, and now let us go for a quick assessment test. Which device uses a microprocessor? Washing machine, laptop, smartwatch. We know that it is a laptop. 8051 is a DAS. It is a microprocessor, microcontroller or FPGA. We know that it is a microprocessor. And can you list some real world application of a microcontroller? Yes. And from this we can come to a deep divide. A microprocessor, we call it as a brains of computers, and it execute complex instructions and also require external components function, that is CPU, RAM, ROM and on PC and servers. If we come to the microcontroller deep drive, it is a computer's on a chip. It integrates everything, that is CPU, memory, input, output and specific task. It is an integrated system, embedded system focus, and it is a specific task focused devices. Applications across industries are automotive, consumer electronics and medical and industrial, everyone. Thank you.